I'm Joanie, your geospatial data analyst. Geospatial data has revolutionized agriculture by providing insight that helps farmers optimize productivity, monitor environmental conditions, and make data-driven decisions. This presentation introduces geospatial data, its significance in agriculture, and key data sources that can be used to enhance farming efficiency. By the end, you will understand the fundamental concept of geospatial data and how they can apply to agriculture. Let's get started. First, let's have a look at what are geospatial data. In fact, they refer to any information that has a geographic component. It means that the data is tied to a specific location on Earth and can be mapped and analyzed spatially. Spatial data can be broadly categorized into three main components. The first are vector data. Vector data represents point, line, and polygon. Vector data use point, line, and polygon to represent real-world features. For example, the boundary of a field as a polygon is a vector data. Irrigation canal are represented by a line, and sensor location can be represented by points. Here I show you a simple feature, so a SF object, which is a multi-polygon, so a collection of polygons that represent Chaudière-Appalaches, so a region in Quebec. In this multi-polygon, we have a bounding box and a geocoding CRS. This same polygon, this same simple feature can be represented in an image as such. So this is the multi-polygon, so the collection of polygons that represent the region of Chaudière-Appalaches. The second category of geospatial data are raster data. They are composed of a grid of pixels, which each representing a value. For example, we can represent satellite imagery as raster data, and DVE, maps, and elevation model are also represented with raster data. So here I show you a spat raster with dimension 16 by 24, so 16 rows, 24 columns, of a 0.1 degree resolution. So essentially, I show you exactly the same region. So instead of showing you the polygon, I have a spatial raster that shows you the temperature of the region of Chaudière-Appalaches. So you can look at the characteristics of the spatial raster like this, or you can visualize the temperature inside the spatial raster. So here, its section of 0.1 by 0.1 degree has a value associated to it of the temperature in Kelvin here. So that's why the legend is a bit weird. The third category of geospatial data are data cubes. Data cubes are multidimensional data structures that store spatiotemporal information. This is useful for managing or analyzing large-scale geospatial data over time. So here, instead of having only one layer in a raster, we have many layers, and those layers represent different time steps. Climate models and hypercurve of soil moisture data can also be represented by data cubes. So why are geospatial data important in agriculture? First, for precision agriculture. By using remote sensing and GIS, farmer can optimize the use of fertilizer, pesticide, irrigation, and the irrigation is based on an actual field condition rather than applying uniform treatment. Soil and crop monitoring. Soil and crop monitoring also use remote sensing tools to access soil moisture, plant health, nutrient availability, and allowing farmers to take corrective action before any kind of problem escalates. Climate and weather analysis use also geospatial data to track and predict climate conditions such as drought, temperature variation, and precipitation trends, which all impact crop yield and farm planning. Yield forecasting use geospatial analysis or geospatial data to analyze historical and real-time geospatial data. For yield forecasting, by analyzing historical and real-time geospatial data, farmers and agronomists can predict yields, helping them plan logistics, storage, and market supply chain. So, now that we know what are geospatial data, why it is important to consider those in agriculture, let's look at where we can find those data. So we have two general categories. We have free public data and we have private paying data source. In the free public data, we have Sentinel-2, which is a satellite that gives us remote sensing data. LANDSAT is also a satellite made by NASA. MODIS data can also give us moderate resolution imaging that is excellent for climate and large-scale vegetation monitoring. Soil Grid made by the FAO gives us global propriety of soil map, which are useful for soil fertility analysis. And Copernicus gives us AGERA5 data, which are a really good sources of high-resolution climate data to make all kind of analysis. In the private data source, we have PlanetScope that gives us satellites, so remote sensing images. We also have drone and different kind of sensor, which usually gives us high-resolution imagery useful for farm-level imagery and many kind of precision agriculture application. In conclusion, geospatial data is a powerful tool in modern agriculture, helping to optimize resources by leveraging GIS, remote sensing, and different kind of sensor technology. Farmers can enhance productivity and sustainability. That's it for my introduction of this mini-series. If you have any question or need help, please drop a comment below. I'll be happy to help.